Hello students, in this video you will find fourth type of solid, atomic crystal or covalent solid or network solid. Three types: molecular solid, ionic solid and metallic solid I have given you in the previous videos. Here atomic solid, let us see atomic crystal point wise. Atomic crystal, first point, the constituent particles. Constituent particles are atoms and binding forces. Binding forces in these solids are covalent bond, network of covalent bond, covalent bonding is there. In these solids, atoms of the same element or different elements are there, and these atoms are held together, attracted towards each other by strong covalent bond. Arrangement of covalent bond extend throughout the crystal lattice, throughout the solid, resulting interlocking giant three-dimensional structure. This is why these are also known as network solid. Interlocking network giant three-dimensional structure means what? These are network solid. Now some examples I want to tell you. Quartz is this kind of solid, SiO2. Diamond is this kind of solid, atomic crystal, and quartz, SiO2. And this carborundum, silicon carbide, SiC, very hard, and this is used for making wash basin, sink also, silicon carbide, and this is a atomic solid. Now here some properties of atomic solid or properties of atomic solid. First, these are having high melting point. High melting point. Second one, high heat of fusion. Third, they are very hard. And fourth, they are poor conductor of heat and electricity. These are some important points to remember. I am going to tell you first about the structure of graphite. Structure of graphite. This is a graphite structure. Graphite is a crystalline allotrope of carbon which has sheet-like structure or layer structure, in which each carbon atom is bonded to three neighboring carbon atoms in the same plane to form a hexagonal ring. Next point, each carbon atom is sp2 hybridized. One 2s orbital and two 2p orbitals are involved in covalent bond formation. And third means one more 2p orbital, third one, having unpaired electron, having one unpaired electron, undergo lateral sideways overlapping with other p orbital of the same atom, that means both are having unpaired electron, lateral overlapping, resulting the formation of pi bond, and these pi electrons of these orbitals are delocalized and free to move. This is why graphite has the property of conductivity. Now this sheet or layer containing hexagonal rings are separated or apart from each other, separated from each other by a space. That space is of about 340 picometer, 335 to 340 picometer between the layer space is there. And the bond distance between carbon atoms in the hexagonal ring is 142 picometer. It indicates that bond is short and it is very strong. And here distance between the space 340 picometer indicates that there is long distance. It means the force of attraction which hold these layers together is weak, and that force of attraction is called van der Waals force of attraction. Now I am going to tell you some structure of these layers. This is a sheet or layer. 2 carbon atoms of graphite bonded here. Here also these carbon atoms are bonded. Next, hexagonal ring is this, like this one, and another is like that. We can make the structure of graphite like that, and another layer. Now see, this carbon atom, only 3 electrons are involved in bond formation. 3 carbon atoms are bonded here, 1, 2, 3, and 4th electrons are free there with the unhybridized orbital which is delocalized. Now here another one sheet I am making now, another layer of graphite. This layer is also there. Like this layer is formed, and like this you can draw the layers of graphite, and here these are the forces between the layers. These forces are there between the layers of graphite. These are the layers or sheet containing hexagonal ring, and this is what? This is the space between the, and this bond distance. This bond distance is 142 picometer, and here this space between the layer, this space is around 340 picometer, long distance. Then here hexagonal unit, hexagonal ring or unit of layer. Then these layers are attracted towards each other by a very weak force of attraction. This is why one layer can slide over the other layer and it is soft. Now, important properties of graphite. First, graphite is soft and slippery. Why? Why is graphite soft and slippery? Because of here space distance between the layers, and these layers are attracted towards each other by weak force of attraction, and this force of attraction is called van der Waals force of attraction. Van der Waals forces of attraction. Van der Waals forces of attraction. This weak force, because of this weak force of attraction, it can slide, one layer can slide over the other layer, and it is slippery and soft, used as lubricant. Graphite has high melting point. Why? Because of a strong covalent bond between carbon atoms, it is having high melting point. Now number 3, graphite is good conductor of electricity due to presence of delocalized free electrons which are free to move. It is good conductor of heat and electricity. Only 3 electrons are involved in bond formation, and 4th electron is delocalized free electron. This is why it is conductor. Number 4, its color is dark gray and metallic luster, and it does not react under ordinary condition with acid, alkali or oxidizing agent, but it react with acidified potassium dichromate solution slowly to form carbon dioxide gas. On combustion, on burning, it forms carbon dioxide. Now these are some important properties of graphite: soft and slippery, high melting point, having low density than diamond because of this space between the layers, good conductor of electricity due to free electrons, and high melting point around 3500, but this is less than that of diamond. Now these are some important things. That's all for today. Again, next video, very interesting topic of the same chapter I will tell you. Thank you.